AppSec engineers. In this video, we're going to be looking at one of the stealthy vulnerabilities that affects a lot of web applications, which is CSRF, or Cross-Site Request Forgery. Now, we're going to look at this from both an attack and defense perspective against a Ruby on Rails application. So let's get started, and let's get started now. If you're enjoying this sort of content, I highly recommend you smash that subscribe button and click on the like so that we get more encouragement from you to put out more videos like this. Outside of that, if you want to get a really handy dandy pre-secure default library guide for your developers. So let's say you want to distribute a bunch of secure default libraries for your developers to use so that you can start building applications much more securely. I highly encourage you download a free guide to these secure default libraries from our website on AppSec Engineer. The link is in the description, so please go ahead and get that free resource to help your developers get more secure when they're writing code every single day. And now, let's get back to the video. Now, before we dive into a lab, we need to first figure out what is CSRF in the first place. Now, CSRF, or Cross-Site Request Forgery, is really an authentication-related issue. Now, let's explain this with an example. So let's say you have an application, and let's say you're a user of an application, and you're using this application on your browser. Now, this application, you will be using it on your browser, and probably you'll have multiple tabs open on that same browser. It's very likely that most of us do this. We have multiple tabs open on the browser when we are browsing multiple sites. And this, our critical application, happens to be one of the applications that's on one browser tab. Now here, let's say on another browser tab, you get another ad saying, win this trip to Las Vegas and click here to claim your prize or whatever it is. Some kind of an ad which looks sketchy, but you don't think it's very sketchy, you go and click it. Now, when you click on the ad, what the ad is doing under the hood is making a request to your application, to your critical application. So let's call this critical application Acme. So let's say you have a particular application called acme.com. Now, once you click on this Las Vegas ad, what it's doing under the hood, as soon as you click on the image is hooked up to an event that triggers an HTTP request to acme.com/account transfer.jsp, transfer amount 1,000 to this account, or let's say transfer amount 1,000 to this particular account. So let's say 123456 is the account number, transfer amount $1,000, and it triggers that HTTP request. And your app, let's say it's not configured to be secured against CSRF. Your app thinks that the request is coming from you because you're logged in on the same browser. You have cookies. The cookies are submitted as part of that request because, again, it seems to be coming from you. And you have now transferred $1,000 to an account that you don't know. You don't have any idea this has happened. You just think you clicked on an ad, but instead something else completely happened. Now, this is an example of cross-site request forgery. So this is typically against state change events, state change like account transfer, change password, etc., etc. Any of these state change events against applications, you will typically see that they may be vulnerable to cross-site request forgery if your application has not been configured to address those issues. So this is what cross-site request forgery is. Now, the way cross-site request forgery happens largely is simply because you're using the same browser. The browser is submitting cookies. The cookies are in the browser, uses the same cookies from the browser to submit it. So your application is not able to recognize a genuine request from a fake request coming from somewhere else. That's the big issue with cross-site request forgery. So we're going to look at an example with a Ruby on Rails app as to how you can attack and defend against CSRF, or cross-site request forgery. Let's get started with our demo of CSRF. Now, specifically, I'm going to be looking at Ruby on Rails application for this. However, if you do have access to AppSec Engineer, or if you're already a user of AppSec Engineer, you'll see that we have CSRF in multiple languages and platforms. So you'll see that there's Ruby on Rails, there's Django, there is Go, there is .NET, there's Java, and there's Java Spring Boot, and we have many others coming up as well. So I'm going to look at this with Ruby on Rails, specifically because Ruby on Rails is a very interesting platform. It's a very interesting framework. So the way we're going to see this in every course of AppSec Engineer, you'll typically see that we have some intro and we have some learning objectives and the way it works, so on. And then we actually get into the attack and the defense. You'll see that's how it works. Let's look at the attack. So the attack with Ruby. Now let's talk a little bit about Ruby on Rails. Because Ruby on Rails by default definitely ensures that most of these security issues are dealt. So unless your developers have turned off that functionality, there's a good chance that your Ruby on Rails application does have some basic protection. It does have some very key protections against CSRF. Now, in this case, we're going to spin up an app that is going to be specifically vulnerable to CSRF. And you will see that because of this vulnerability, we're able to perform a state change operation against CSRF in a very serious way. So let's look at how this works. We're going to look at the attack first, and then we're going to look at the defense. All right. So we'll spin up the lab. Now I'm going to fast forward through the lab spin up. It takes about 30 seconds. I don't want you sitting around, waiting around for 30 seconds for the lab to spin up. So the lab is spun up. Now let's actually go ahead and access it. Now we are accessing this lab on AppSec Engineer. So you'll see that you can access the lab entirely on the browser. And we have a developer environment that is already pre-set up for us to actually go over the code, do whatever we need to do. Now I'm going to move the instructions. So we do have detailed instructions for each lab. I'm going to move the instructions over to my other screen so that it's just not interrupting in this particular screen. So we have an application here, which is Ruby on Rails. So you'll see that this is a Ruby on Rails application. It has a gem file. It has the controllers. It has config and so on and so forth. It has all of those necessary dependencies for a Ruby on Rails application to work. Now you will see that we have passwords controller, which is the one that is vulnerable to this. So you'll see that the password controller has an issue here. There is a vulnerability, which is skip forgery protection. So we've made a huge mistake, which is the developers made a huge mistake, which is skip forgery protection. Luckily, with Ruby on Rails, you don't need to worry about this. If you're using Ruby on Rails by default, it automatically has forgery protection. So it's quite secure by default. But if you're not, you need to ensure that it doesn't have these kind of things. So definitely when you're using Ruby on Rails, to ensure that you need to have these features, these things like forgery protection, not skipped. Obviously, that's what you really want to do. So in this case, anything related to the password controller, which is the create password, or you're signing up the user, or when you're trying to create the user, or when you're trying to update the user or update the password in this case, it's not going to have CSRF protection, which is happy. Now let's actually go ahead and run this app and see how CSRF works for ourselves. Let's say taste of the pudding is in the eating. So let's actually go ahead and run this. Now, this is something you should definitely not do, which is turn off key features. So the first thing we're going to do is we're going to build the container image. We have a Ruby container. We're going to build it, and we're going to build it with this code base, which is now vulnerable because of this configuration. So this is bad. Obviously, don't turn off security features that are enabled by default. A lot of people turn them off because they think it's not necessary, or they don't know what it does. They would have seen a tutorial sometimes. They're not fully sure about what the vulnerability is and whether it's required. They might have misdiagnosed some other issue related to this, or that might have happened. So definitely this does happen more. So definitely make sure that this is not happening. Your developers need to know that skip forgery protection is a bad deal. So we're building our container. This takes a little bit of time to spin up. We're running a container image, which is in here. And you'll see that it has installed. It runs all the necessary dependencies. It installs all the necessary dependencies from the gem file. And then you have this. Now, this is done. And now we can run the app. And let's actually go ahead and run the app. We're going to use Docker Compose to run the application. And we're going to be using a database for this. Let's look at what database we're actually using in this case. We're using Postgres, and Postgres is going to be linked to this particular Ruby on Rails application. So we're going to spin up the database first, and then we're going to run the web application. Both of these have started. If I do attack.ps, you'll see that our application is running and our database is also running. Now let's go ahead and watch the application. So this would be, so I need the name of that particular application. So I just need to run a particular, web. So we have it in here. Now what we're going to do is we're going to run the CSS on top of it. We're running a Tailwind CSS top of it. So we're going to just run this command to spin up the necessary CSS dependencies for it to work. Now we have all of this done, and we should be able to access this on the same URL on port 8880. So let's go to HTTP port 8880, and you will see that Ruby on Rails application is running. It has sign up screen, sign in screen, all that stuff. So let's first sign up and say test at test. I'm going to give it a password. Hopefully it doesn't have password requirements. No, it does not. Now, what we are going to do is we are going to spin up a simulation of this particular vulnerability. So we're going to simulate this particular vulnerability. We're going to open another terminal right here, and we are going to make a change to our attacker. So we're going to behave both as the attacker and the victim in this particular case. And we are going to spin up. So we're going to download a particular ad. So imagine that you've opened this you have this application open on one end, and now you have the application open. You have that ad. You remember I spoke about the ad that was giving you that trip to Vegas. So now we're going to have that advertisement simulated, right? So we're going to look at how that works. So we have this CSRF. We're going to download that, and we are going to open that. Okay. Yeah. So we're going to open this. So this HTML page has a form. So imagine this was an ad or something like that, and it has this form. Obviously, you should not be able to submit this to this actual application, which is this. You should not be able to submit this to this particular application, but it is possible that you should be able to do it. So now let's actually change the password, and let's see what's happening in the browser window. So let's actually see my password manager. Yeah. So let's look at the network. I'm going to change the password, and let's see what this does. This makes request. Instead of using this set command, I should have done this. It's just port 8880 password. This should do. Now let's download this file and run it again. This time, let's change the password, and hopefully it should change the password. If the attack works, you'll see that it changes. Looks like it did it. Yeah, it looks like it did it. So it did something. It made a request to the password, and it seems to have changed. Now, let's try and log in. Let me be the user who tries to log in with the password I'd created before, not the one that the attacker was able to change the password. If I'm trying to log in as that password, it says no, incorrect email or password. So you'll see that the attacker has been able to create this form. And because they created this form, they were able to force my application to just accept the request without my application actually doing any kind of validation. My application is clearly not validating whether it is coming from the same request source. It was not validating any kind of token. None of that stuff was happening. So you will see that the application is vulnerable. So now if I log in with the changed password, which was forcibly changed by the attacker can now access my account and completely do everything with that particular account. So you'll see that this is a very dangerous issue. It can have massive implications for your application. So this is a very serious issue. It's a very stealthy issue. Most times people who are affected or people who are victimized by this don't even know that it's happened. So a lot of times that is one of the issues with CSRF. Now let's look at the defense and how we can defend against CSRF. So in the previous video, we looked at a CSRF attack where we actually took a real world application and we had this other application, this other form that was opened outside. Let's say there's another tab that was a malicious applications tab that was open, and we were able to get that to make a password change request to this particular example here. So even without the user initiating a password change request, just because it was that particular user, they were able to change that password, which is a huge problem. Now let's look at, and this was the reason. So this was the malicious form that was set up by the attacker. And all the attacker did was set up the action to go to the actual legitimate URL. And they were able to change the password to whatever the attacker wanted to change it. So this is a problem. This is a pretty big issue with CSRF. Now let's actually spin up another defense example and let's see how it works. Now, what we're going to do is we're going to spin up an example related to the defense, and we are going to see how this. So I'm going to wait for the lab to spin up, and we're going to fast forward through to the point where the lab is completely spun. All right, so the lab has completely spun up now. Let's actually look at the defense part of it, and let's make a few changes to our vulnerable app. So this is the same vulnerable app. The app does not change. We're going to make a few changes to the defense, to the application to make it more secure. Basically, what we are going to do. So let's open up the terminal. And the first thing we're going to do is we are going to add some CSRF meta tags to the forms. To each of the forms that we have, we're going to add some CSRF meta tags. We're going to run this particular command that's going to add the CSRF meta tags to the template form that is going to be there, the HTML template that we have. So let's actually look at what this has done. So this would be in Ruby, CSRF, views, and layout. So this is the base template that we have. Now, the base template itself, you will see that we've added this meta tag. So previously, this meta tag was clearly not there. Now we have added this particular meta tag. We also need to add the skip or remove the skip forgery protection from our controllers. So when the request is coming into our controllers, we want to be able to enable forgery protection and not just skip it. So that we can also do with this command, which is instead of skip forgery protection, we want to comment that function. We want to enable forgery protection. So we don't want it to be skipped. This is in the passwords controller. We also want this skipped. We also want to remove the vulnerability from the sessions controller. So if you look at the sessions controller and the passwords controller, we have removed the skip forgery protection. So which means you've added forgery protection, obviously. So you'll see that in both cases, we have removed the skip. So the other thing, which is also something I'm not sure whether you noticed, was that there was a huge issue with the previous example where there was no authentication required to change the password at all. So that's obviously a problem, which means that you need to remove that. So before this action happens, the user needs to be authenticated. If you take this, there is an instruction here to do all of this. So changing this to, you can see that we've done that for this. We've done that for the passwords controller, and we're going to add an additional directive now, which is going to be forgery. So we're going to add something called protect from forgery with exception. So every time there is a forgery, it's going to throw an exception saying that, hey, this is vulnerable to. You're trying to perform a CSRF attack. So it's going to protect from forgery. So if you look at the application controller.rb, you will see that we're going to add protect from forgery with exception. And we are going to have, this actually was not required. We don't need this for password controller is what we need it for. We don't need it for sessions controller. This is fine. All right. So I'm not sure whether I made some mistake while setting up this. The instructions are clear here, but I was talking, so obviously I'm not sure. Well, I did make a mistake. Let's figure it out. All right. So let's now go ahead and run this application now that we have fixed it. So we've done a bunch of fixes. The first thing we've done is that we have enabled on the application template, we have enabled the CSRF meta tags, and in the passwords controller, we have removed the skip forgery protection vulnerability that was there. We have added before action authenticate user. For any of these routes to be invoked, you need to be authenticated for an edit or update to happen. The same thing for the sessions controller. We have removed the skip forgery protection directive. And obviously, if authenticated, redirect only for created new. So we've added that also. So that was already there. So we didn't need to do anything with that. And for the application controller, we have added a baseline protection, which is protect from forgery with exception. So whenever there is an attempted forgery, it would throw an exception and it would throw the user. That's basically what we're doing here. So now let's actually go ahead and deploy the application, and we don't have anything running. So we're going to build it from scratch. This is another virtual machine. So we're going to have to build it from scratch. And once it's built, we can run this and get it. Yeah, I didn't need to do the build thing. I could have just, but that's fine. In any case, we need to spin up the database server as well. So you don't need to worry about that. So the same Postgres database, the same everything. And we're going to do the same thing. We still have the CSRF farm somewhere in here. We're going to try and compromise that. And we're going to use that to see if we can make that work this time. Hopefully it should not, because we've added a whole bunch of directives to protect this application against CSRF. The other thing we can do, and I recommend you do, is add a same site session token, right? Session cookie from the browser. So if you enable same site, the browser itself will not allow you to make requests to a third party URL from some. So let's say a random URL is trying to access your application as a form request. And if you have same site cookies enabled on that application, it won't allow you to just make those random requests. So that is something you can do as well. So now let's spin up the box. Let's spin up the application. We're pulling the database, and then finally we're going to pull the, so we have the same thing, and we're going to exec, docker exec the bash. Now we are going to run the CSS, the tailwind work. We have it. So we have the CSS compiled. So now let's actually run the same example like we did before. So now we have the CSS done. Now let's actually go ahead and run the application and actually verify whether it works as intended. Now I'm going to sign up at abhay@secure.com. My password is going to be test and test. So now I'm going to have a password test and test. I'm going to sign up. Now here you will see, first of all, you will see that on this itself, let's look at the first thing we've done. First of all, if you look at the inspect on the form, you will see that this form now has a CSRF token enabled. So automatically there is a token enabled on the form. So that itself is the first thing. That was what we did. We also added a meta tag. We added a CSRF meta tag, and that's the meta tag that we added to the head of the HTML. All right. So now if I log in with my password, it should work just fine. But that's not really what we're looking at here. We want to check whether it works, whether CSRF works or not, whether I'm able to change, whether somebody else is able to change the password form. Now let's go ahead and make a change to my CSRF. I've downloaded the attack HTML form, which is my form that makes the change to that password. And I'm going to make a change to that. And I'm going to make one change to this, which is change the URL, or change the first part of the URL. So the idea is that the attacker's form should now submit to this application. So instead of the VZ whatever thing, I'm going to make it this, which is defense lab. Hopefully it should not work. Now I'm going to open that attacker form in another window, and this time around I'm going to open up developer tools, and I'm going to change the ID of to something else. I'm going to change it to super secret. To change the password, let's see whether it works. No, sorry, it does not work. So it means there is a referral policy set up. This makes it impossible for Rails to verify the source of the request. So the authenticity token, it throws an error. Remember the exception that we added in the application controller, we added exception. Of course, you should not be throwing full-fledged stack trace exceptions like this in production. But just to give you an idea, this is how it works. So this is how typically it works, where to add an exception, you can just route it to a generic error page that says, sorry, invalid access or whatever it is. So that makes it much more powerful, right? So in this case, we have a very clear definition saying that, hey, if somebody tries to perform a CSRF attack, throw an exception. It doesn't work. It's a 422 error comes back, which is good. So now we have effectively protected our application against CSRF. So just to be clear what we've done, we've added CSRF meta tags here to the HTML templates. We've added protect from forgery. This is what threw the error here, protect from forgery. This is what threw the error with an exception. Ideally, this exception should be routed to a generic error page, which makes life a lot easier to manage. And you can log the exception in the backend. Then make sure that you do not have skip protection because that's very important to have. And we made sure that for the passwords controller, only somebody can change passwords when they are an authenticated user. Otherwise, they can't, which should have been done even before. This is what we're protecting ourselves, our Ruby on Rails application against CSRF. The good thing with Ruby on Rails is that it automatically is secure by default. So even without you do anything, it will give you defenses against CSRF. So that is something to keep in mind.